Here's an absolute value equation. You may already know that the absolute value is the distance that a number is from 0. And there are two numbers that have 42 as their distance from 0. Positive 42 is 42 to the right of 0 on a number line, and negative 42 is also 42, but to the left of 0 on a number line. So there's two solutions to this equation. N can be 42, or n can be negative 42. A slightly shorter way to write the solution is shown here. N is equal to 42 or negative 42. A more formal way is to show it as a solution set, and this is read, n is a member of the set of numbers 42 and negative 42. And a real short way to write this answer is this symbol, the plus minus sign. I looked for a more formal name, but I couldn't find one. All of the sources that talked about this symbol all just called it a plus or minus sign. But it means that there are two answers here. And when you write plus or minus in front of a number, you're really writing two numbers, although it only looks like you're writing one. It means both positive 42 and negative 42. Here's another absolute value equation. The absolute value of a number is negative 42. Well, if you remember our look at absolute values in a much earlier lesson, you know that absolute values cannot be negative because they represent distances. So there is no solution to this equation, and we put the empty set symbol as the quickest way to show that we know there's no solution to this equation. And here's an absolute value equation that has one solution. 0, of course, is 0 units away from itself. The absolute value of 0 is 0. The opposite of 0 is also 0, so there's only one answer. So the absolute value of a number is 0, then the number has to be 0. Now let's look at a more complicated equation. The absolute value of a number plus 8 is equal to 30. Now you could probably figure this out in your head using a little bit of trial and error, but another way is to use substitution, or as one textbook I use called it, chunking. We say, let the expression n plus 8 be a, or we could say let a stand for n plus 8. So now we have the absolute value of a is equal to 30. And then we get, of course, just like we did for the absolute value of n is 42, we got that a can be 30 or a can be negative 30. But let's remember that a stood for n plus 8. So we substitute the n plus 8 in for the a. Then we write it down below, n plus 8 equals 30, or n plus 8 equals negative 30. In both equations, we add negative 8 to both sides, and we get that our two answers for n are 22 or negative 38, and we can also graph them, as shown. A shorter way to write the equation is to not use substitution, or as the one textbook called it, chunking, but just to split it in half right there. Know that the expression n plus 8 could either be 30, or the expression n plus 8, the one that's inside the absolute value, could be negative 30, because then the absolute value would change it to positive 30. So we just split it right away. We add negative 8 to both sides. We get our two solutions, and then we graph. Here's another equation. We split it into two parts. Either the stuff in the absolute value can be 36 or negative 36. The stuff is 4n take away 6. We add 6 to both sides in both cases. We divide by 4 in both cases. And in this case, neither of our answers are integers. We're not worried about that. We can still graph them. There are our two solutions. Here's another one. Either 5n plus 18 can be 13, or it can be negative 13 because of the absolute value symbols. We add negative 18 to both sides. Then we divide both sides by 5 in each one of the equations. One of our answers is an integer, and the other one isn't. But there's our two solutions. And you can test them both. The negative one is easy to test. You do 5 times negative 1, you get negative 5. You add 18, you get 13. And you say, is the absolute value of 13 13? Yes, it is, so it checks out. The negative 6.2 is a little bit harder to check, but if you do 5 times negative 6.2, you'll get negative 31. you'll do negative 31 plus 18 to get negative 13, and then when you take the absolute value of negative 13, you get 13, so it checks out. Now here's one a little more complicated. We have an expression inside the absolute value added to 4 to make 20. Well, before you split this into two parts, add negative 4 to both sides. So now we have the absolute value of the expression 8n minus 15 is equal to 16. Then we split it into two parts, and in both parts we're going to add 15 to both sides and then divide by 8. And it's another problem where neither solution is an integer. I wrote them as decimals, but the first one could also be 3 7/8, and the second one is negative 1/8. And then we can graph both of those as shown. Here's one. We need to get the absolute value all by itself on the left side, so we're going to add negative 24 to both sides. And now we're saying that the absolute value of an expression is a negative number, in this case negative 11. So we can stop right here and say there's no solution to this equation. Here's a very similar one, but I altered it a bit from the previous one, so it's not an identical equation. I changed the plus 24 to plus 13. I add negative 13 to both sides, and I get 0 on the right side. So this is an equation that will just have one answer. So we don't need to split it, because if we have negative 0 and positive 0, that's the same thing. So we just do this problem once. Doesn't come out even. It's 12/11, or as written as a decimal, 1.09, where the 09 repeats. And we can graph that. There's just one solution to this equation. Equations involving absolute value of the type shown in this lesson may have 2, 1, or no solutions. When solving an absolute value equation, use transformations as necessary to get the expression within the absolute value symbols by itself on one side of the equation. Then split the equation into two equations, with one equation being the expression within the absolute value symbols equal to the other side of the transformed equation, and the other equation being the expression equal to the opposite of the other side of the equation.